Hi everyone, it's Coach Fred here, and I'm going to be going over question number 17 from the review packet on quadratics. So it says for the function g defined above, a is a constant. And that we keep going back to just means that a is a number, okay? It is a number. I know it looks like a variable, but by me saying it's a constant, it's a number. And g at 4 equals 8. So we know that on this function, that the input of 4 would give me 8. So that is a coordinate that is on this point. It wants us to find the value of g at -4. Well, there's two ways to consider this. If this is a function, if this is a constant, and we have our input and we have our output of 4 and 8, we can plug them in to find our a value. Like so. So we can substitute in the x and the y, because remember g of x is another name for the y, the output, and then solve for a. So that gives me 16 plus 24. Subtract 24 from both sides, and I'm going to get -16 equals a times 16. And then to solve for a, I'm going to divide by 16, and I get -1 is a. So that tells me that the function, that the constant a, is actually -1. So I'm going to write that as -x squared plus 24. So now I have a function with no additional constant. To find the value of g at -4, this is my input of x, and I want to find my output of y. So let x be 4 and solve for y. So I'm going to plug in, I'm going to find g at 4. G at -4. So I'm going to plug that in. So -4 squared plus 24 gives me -16 plus 24, which is also 8. And remember, this was 16, and then I had a negative in the front, and that's how I got 8. So g at -4 is 8. Now, another way to think about this is the graph. The linear term of this quadratic is missing. And so this is my y-intercept, which tells me that this is a graph that's just been shifted up to 24, okay? So here it's got the vertex is essentially the y-intercept at 24. And if I know that g at 4 equals 8 right here, and this is the vertex, then I know that because of the axis of symmetry that g at -4 would also be at a y value of 8. That's thinking about it graphically, okay? So this is thinking about it numerically, and this way is thinking about this graphically. All right, hopefully that was helpful. Have a great day.